Well, if that's what happens there, then what's going to happen is it will, rather than just say, okay, it's defined, it will put a value of 100. And maybe later in your code you'll say int m is equal to max. You see this right here? So if the preprocessor comes across this pound define, it makes an entry into its table. Oh, I remember this. That's defined. Be 100. Erases it, puts 100. No more pound defines, no more pounds. Continue. It will hand off to the compiler. This is gone, this is gone, this is gone, this is gone, replaced by 100. Okay. So that's an example of a preprocessor directive. Define something. Now, if you said pound define this, then what the preprocessor would do, it says, okay, pound or max is defined. It's not 100. In fact, the only thing we have is that it exists. So therefore, it says this, makes this entry. Oh, that's defined. What's the value? Okay, nothing. Erases it. It says int m is equal to semicolon. Hands it off to the compiler. Compiler is not happy at all. So the compiler only sees this, which is not legal. Okay. All right. Now another thing, another preprocessor directive is the pound include. Pound include is like a Java import. Here's how it works. Typically, what you're going to do is you're going to pound include header files. So if I have, let's say we have something called module 1 and module 2. Module 1, let's just say for simplicity, is going to contain only the main method. It will be the driver of this program. In module 2, let's say it's going to have the function f, the function g, the function h. So it's going to have these exports, if you will, right? You will define these functions and export them. Now, let's say the main is going to be 100 lines of code. And let's say f, g, and h together are going to be 100 lines of code. Let's say it's going to take me approximately 2 days to write these codes perfectly. I'm just exaggerating. And it's going to take me 2 days to write these lines of codes perfectly. So in order to accelerate my developing time, I'm going to hire a crackerjack programmer. I think I see about 50 of them in here. And let's use Ruben this time. And so I'm going to tell Ruben, okay, Ruben, I want you to write the main. I want you to write it, and I want you to, but I don't have this done at all. Not at all. I don't have this done. But I want you to be able to compile your code. Now keep in mind that these modules are going to be connected because the main obviously is going to be using F, G, and H, right? So there's going to be calls. So in order for him to compile his code, he has to declare these functions here and then call them. The compiler then can, so for example, let's say this is void, you know void, right? Void, let's say this is double, let's say this is int, let's say this is, again, there could be different parameters. Let's say this is an int coming in, there's some code. Let's say this could be a class, for example. Let's say a class called string, some object code, etc. So basically, this function returns nothing. It takes an int. This returns double. Takes a string. This takes nothing. Returns an int. These are the signatures, the prototypes, the headers of these functions. I am going to be writing this code, but I want Ruben and me to start exactly at the same time, so that in 2 days we can come together with compiled programs and link them. In order for us to be able to start working together, we have to agree what are the prototypes going to be? Void f int, double G string, int h nothing. If he takes this code and sticks it over here, void f int, semicolon, double G string, semicolon, int h, nothing, semicolon, then those are being put up there as imports. So they will be declared by his compiler as imports. So therefore, when he compiles this code, and he makes calls to G, and calls to H, and let's say G, and then he calls to F, then those calls will be checked against those prototypes. And the compiler can check, okay, you're calling it appropriately, therefore your code is good. All right? So he can start working on this. Now, imagine that my module 2, instead of having 3 functions, it had like 50 functions. That's not super unusual, 50 functions. So if I followed the same model, I would have to put 50 functions on top of my code. So my code is going to start on page 3 of my screen. I have to go to page 3 to even see my code, because I got prototype, like this. Rather than doing that, module 1 is divided into a CPP file and an H file. Guess what's in the H file? Header, header, header. Declare. Define, define, define. So once I make this CPP and header file, all I need to do up here is say pound include, let's call it mod2.h. Once I do that, and the H file, so the H file will just be header, header, header. Semicolon, 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 no code. Once I do that, I can give this to Ruben. He can code and compile his program. 2 days later, assuming my functions are working correctly and have the same, I'm still using the same header file, because I'm going to use the same header file. Therefore, my implementation will also check to make sure that the header matches the implementation. So we're going to use the same header file. He can compile his program, but he can't what? Link it. I can compile my program, but I can't link it. We have to put our modules together, and then we can link it and try to run it. So these are just some simple examples of preprocessor directives. They can get a little more interesting, but basically that's the idea. So the preprocessor does its job basically before the compiler ever gets to it. Okay, so what about these other ones? Well, we'll look at these soon enough. So how about if I don't even bother you with that right now? Pound if def. Pound if def. Well, see, pound define? Pound if def, if you pound define max, and then you say pound if def max, code, 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 pound end if, then if it's defined, then the code inside the if def end if is included to the compiler. If you erase max, I'll show you, this will be the last thing I'll show you. So, suppose what you wanted to do is you wanted to run your code in 2 modes. One of them is the regular mode, one of them will be a debug mode. So you can say pound define, we're going to put debug. Do you notice that my, well, it's red, isn't it, right? Do you notice that my debug is capital letters? Do you notice that my max was capital letters? Do you think it's a coincidence? No, it's a convention. So your pound define constants should be capital letters. If you have more than one word, underscore, that's the convention in C, in C++. So I'll pound define debug. And then I'm going to have pound if def debug What object do we use in C++ to send stuff to the screen? Cout. So cout. That's an object. Java people is like system.in or system.out. What is this? It's an output operator. I'm going to say x is equal to x. How do you create a new line in C++? How about what something else? E, N? Okay. Okay, so very simple. Okay, obviously I'm skipping a lot of other code, but this is just a little piece of code. So what we have here is we pound, define, debug. So this is, so again, there could be code here and code here, but this is still code. This is C++ code. Notice that C++ code ends with a semicolon for statements. But preprocessor directives, they don't have any semicolons because they're not really C language. They're just preprocessor, they're strings. Pound it. Oh, I forgot my pound. What happened to my pound? Okay. So now, the preprocessor defines debug in the table. Code, skip. Oh! Preprocessor directive, if defined debug. Yes, it's right here. It's defined. It doesn't have a value, but it's defined. Therefore, everything here, it goes end if. This closes this if. What happens is, this code inside here is passed to the compiler. Where's the compiler? Here. If I erase this, then this conditional preprocessor check says false, and everything from here to here is eliminated from the compiler. So basically, I can just define this and undefine it, and of course, I can do it in the program. I can also run my C++ program saying -d debug. And that means define debug. So you can actually define preprocessor on the fly. So this will basically include the code if debug is defined, skip the code if it's not defined. So you can, so all your debugging could be in your program. So your compiler will not see this code because it's not defined. And if you say pound define debug 16, nothing's going to change except the code will be included. Debug is 16. Okay, so who cares? If define debug, it's defined. I don't care about the 16. True, everything passes. So the 16 doesn't affect anything because this is a conditional check. If it's defined, it's not saying replace it. All right, so I'm going to stop here. It's a good time to stop. I will be working on the Canvas site, so I'll be uploading lectures. You'll be able to see my PowerPoints on the Canvas site. I will send you an update on that. We have an awful lot of people. I don't know how we're going to deal with that, but anyway. How many people did you say? 47?
It was 47 and 3 people.
Oh, 3 people came in. What's 47 plus 3 quarters? Okay. Okay, thank you very much.